Module 1. Internet Foundations. The OSI model explained simply.
Networking is complicated. Thousands of devices, cables, signals, and software have to work together every time you send a message, open a web page, or make a video call. To make sense of all this, we use something called the OSI model, a simple 7-layer blueprint that explains how data travels across a network. The OSI model is not how the internet is built. It is just a way to think about how networking works. Today, we'll break it down in simple terms.
What is the OSI model?
The OSI model is a framework that describes how computers communicate on a network. It splits this process into 7 layers, where each layer does a specific job. Think of it like a factory assembly line. Every layer has one job, and they work together to send data successfully. Let's go through each layer, from bottom to top, using simple language.
Layer 1. Physical.
Cables, Wi-Fi, signals. This layer is all the physical hardware. Copper cables, optical fibers, Wi-Fi radio waves, anything that moves bits of data as electrical or optical signals. It sends raw zeros and ones.
Layer 2. Data link.
Error checking, local delivery. This layer organizes raw bits into something meaningful, called frames. It handles communication between devices on the same local network, like your laptop and router. It detects errors in data sent over the local network.
Layer 3. Network.
IP addresses, routing. Think of this as the postal system of the internet. It decides which path data will take and uses addresses like IP to deliver data to the correct destination. This layer allows communication across long distances, not just local networks.
Layer 4. Transport.
Breaking data, reliable delivery. This layer makes sure data is delivered correctly and in the right order. It manages how data is split, sent, and reassembled correctly. It's responsible for reliability.
Layer 5. Session.
Managing connections. This layer manages ongoing conversations between devices, keeping them open, synchronized, and properly closed. It starts, maintains, and ends communication channels.
Layer 6. Presentation.
Formatting, encryption. This layer formats and translates data so applications can understand it. It may also compress or encrypt data. Think of it as a translator and formatter between systems.
Layer 7. Application.
What users see. This is the layer closest to the user. Web browsers, email apps, messaging platforms, all live here. It turns raw data into meaningful content.
How data travels.
How data moves through layers. When you send data, it moves down through the layers. When it's received, it moves up the layers. Imagine you're sending an email. The application layer prepares your message. Presentation formats it. Session opens a connection. Transport splits it into chunks. Network chooses a route and addresses the chunks. Data link packages them for your local network. Physical turns everything into signals and sends them. At the other end, this process happens in reverse until someone reads your email.
Why OSI model matters.
So why do we care about this 7-layer model? First, it gives us a common language to describe networking. Second, it helps us troubleshoot problems. If your Wi-Fi isn't working, you might check the physical layer. If a website isn't loading, you might check network or transport. This layered approach makes complex systems simpler to understand and fix. Engineers use this model every day to isolate where a problem is happening. OSI model. The OSI model is a roadmap of how data moves, broken into 7 easy-to-understand steps. Physical, moves bits. Data link, local communication. Network, routing and addressing. Transport, reliable delivery. Session, manages conversations. Presentation, formatting. Application, what users see. Once you understand these layers, networking stops feeling like magic and starts feeling logical. The real internet mostly follows a simpler model called TCP/IP, but the OSI model helps us understand it. So far, we've seen how data moves through different layers, from physical signals all the way up to applications you use every day. But there's one big question we haven't answered yet. What stops someone else from reading or tampering with that data while it's traveling? Stay tuned to keep learning.